Assalamualaikum and very good morning. So I'm Nurul Azrin Ardini Muhammad Zohan, matrix number 200504. So today I'm going to talk about approximate function using tangent plane. So the first example, let S be the cylinder of, S is the cylinder of x square plus y square plus 4 equals to 4. By the way, this first example is the guided one, so we have to find the tangent plane. Find tangent plane at the point 1, 3 and 5. So the first one, we have to identify that this is the X, Y and Z. So our first step is we have to parameterize the surface S. So we can see S can be expressed as the cylinder coordinate SR equals to 2. It means that, let me sketch the graph. S, Y. This equation indicates a circle with the radius 2, because of square root of 4 is 2 or negative 2. So we have here 2, negative 2 and negative 2. So now we parameterize the surface S using theta and Z. First one, we will try to find the theta. Okay, so let's say we take a triangle in this area to find the theta. So let's say this is the theta and we know this is 2, or simply like this. So we take this triangle out. This is the theta and we know this is 2, and given the value of y here is 3. So we can see sine theta is 3 over 2. We can simply get theta equals to pi over 3. Same thing given in the equation here. So now we have to do the parameterization that we get is theta Z equals to 2 cos theta to sine theta and Z, and we have the point 1. This is the point 1, 3, 5. Notice that 2 cos theta here is 1, 2 sin theta here is 2 sin theta is 3 and Z is 5. Look, since sin theta is 3 over 2, so we can know that 2 sin theta is 3. Same thing happens here, and we know that cos theta it is cos pi over 6 is a half. So we know that 2 cos theta is 1. Same thing happens here. Okay, so we have the R. We have R pi over 3, 5. Okay, so we go first with our theta. We have -2 sine theta, 2 cos theta, and 0 implies 2 r theta. For pi over 3 and 5, we will get -3, 1 and 0, because we have 2 sine theta equals to -3, so simply -2 sine theta, we have -3, 2 cos theta, we have 1, and 0, we have 0 here. So we go next with our z. We have 0, 0, 1. This implies to our z with pi over 3 and 5 equals to, we have 0, 0, and 1 as well. So, since both of r theta and r z will lie in tangent plane, their cross product, we have to do the cross product of these two. We have I, j, k of -3, 1, 0, 0, 0, 1. So we know I will be 1 times 1 minus 0 is 0. J will be -3 minus 0, we get 3, and k will have 0 minus 0 equals to 0. So same thing we get here, the cross product. We have 1, 3, and 0. Sorry, this is 1. So we have the cross product of 1, 3, and 0. So that is the normal vector of the plane. So we know that the point given 1, -3, and 5 will lie to the tangent plane. So we can set the point of x, y, z such that the point of 1, 3, and 0, we can multiply dot product with x minus 1, y minus 3, and z minus 5 equals to 0. Or we can make it like this: 1 is 1 plus 3 of y minus 3 equals to 0. Okay, because basically it is the difference between the point and the point where x equals to 1 and y equals to 3. We multiply the point of the tangent plane and the normal, because when normal we times by the tangent, we will get 0. So this equation makes sense. Now we'll move to the next example. Let S be the surface of z equals to y sine s. We have to find the plane to tangent to S at this point, pi over 6, 2, and 1. So like the first one, the first thing is we have to parameterize the surface. So we have the surface z equals to y sine s, we have the point pi over 6, 2 and 1. Let's focus that this is s, y and z. Okay, so now what we have to do is we can use the y and s as our parameters, and this gives us the parameter of r s y. We can make it as y and 2 sine s. Okay, first we have to notice that x here is pi over 6. Okay, and now the sine x is sine pi over 6 is equals to 1. Same thing happens here. 2 sine s is 1, y is 2, and s is pi over 6. Okay, so at the point pi over 6, 2 and 1 is, then r is pi 6, 2, because we take r as y. Okay, so we have r as y is like this. R as y is s y 2 sine s. And now we will go to r s equals to, this is what doctor has been given in the question 1 O and the question mark. So I'll try to fill this question mark here. So doctor wants the r as b 1, 0 and something here. So we have r as 1, I can see that 2 sine s, and the 0 here we simply put 0, and the question mark there. We know that at the end we will get 1, 0, set 3. So to find the set 3, I take 2 cos s, because 2 cos pi over 6 we will get set 3. Okay, so moving to the r y, doctor give here 0, 1 sine s, 0, 1 sine s. So my r y is, r y of pi over 6 2 here is 0, 1, 1 over 2, because sine s, sine over 6 is 1. Okay, let's make the correction here. This is 2 sine s, 2 sine s is 2, sine pi over 6 is 1, because sine pi over 6 is half. Okay, so now to find the normal of the tangent plane, okay, just now we said that this point is in the tangent plane of the plane y equals to sine x. Now let's find the normal. To find the normal, we have to take our rx of pi over 6 and 2 and ry pi over 6 and 2 of the cross product I, j, k of the one, 0, set 3 and 0, 1, 1 over 2. We will have I equals to 0 minus set 3. We will have negative set 3. For j, we will have negative half minus 0. We will have half. For k, we will have 0 minus 1. So we will have negative 1. So the same thing we have here. Sorry, I forgot to put negative here. So the same thing we have been given here. The cross product is negative 3, negative half and 1. Negative 3, negative half and 1. So we can conclude that the negative 3, negative half and 1 as minus the original point given here as minus pi over 6 y minus 2 and z minus 1, or we can make it like this: set 3 times x minus pi over 6 minus 1 over 2 times y minus 2 and plus 1 times z minus 1 equals to 0, because the dot product of the tangent and the normal of a point is 0. Okay, that's the end of example number 2. Now we'll move to the example number 3. Let S be the graph of fxy. That is, S is the surface z equals to fxy, and we'll have to find the tangent plane of S at this point. So we write first. We have S at fxy, and S is the surface at z equals to fxy, and we have to find the plane tangent of S at the point A, B, and f of AB. So now the first thing we need to do is parameterize the surface of S. So since z is expressed in terms of x and y, we can use the x and y as our parameters. So now we have the parameterization of r x y equals to x, y, and f of x, y. Then the point is A, B, and f of AB. So we can have here r of x. We can have x 0 and fx 0. That give us r A, B such fs of a b, and for ry we can have the x is 0, y remains y, and f of 0 y. Okay, so we will have 0 remains 0, 0, and for y we have 1 and fyab. Okay, so the normal vector of the tangent plane is the cross product between these two. So we do the cross product. We will fill the blank here. So the cross product of we make the cross product first, I, j, k, and we have 1, 0, fx, ab, and 0, 1, fy, ab, right? So we will find the I, 0 minus fx of a, b, we will have negative fx, a, b. For j, we will have negative of fy, a, b minus 0, and we will have negative fy, a, b. And for k, we will have 1 minus 0. We can have 1. So now we can see, to fill the blank here, it is the cross product between what we got just now, the cross product of negative fx a, b, negative fy, a, b, and 1. We cross with the x minus a, y minus b, and z minus f of a, b equals to 0, because the tangent and the normal, tangent multiplied by normal must equal to 0. Or we can write it like this, f of x, a, b times of x minus a. This is the cross product between here and 1 there, minus fy, a, b times y minus b, and plus 1 times z minus f, a, b equals to 0. So we can rearrange that as z equals to f of ab plus fx of ab times by x minus a plus again fy of ab and y minus b. Sorry, I can't see. Okay, that's all from me. Thank you.